Okay, let's continue 3.3 with the second section, and let's take a look at number 10 right here. Now, we're going to look at problems that are a little more complicated. Specifically on number 10, hopefully you notice that there is something different about this question as opposed to all the ones that we've looked at in 3.3a. And hopefully, remember, one of the things that I mentioned in 3.3a is that your a term cannot be greater than 1. And it says you can't complete the square. Well, it doesn't mean you can't complete the square, but there is something that you need to do first. So if I take a look at number 10 and I realize, all right, my a term is 2. Well, what could I do right here to take that and turn it into 1? Well, what I can do right here is take each and every term and divide it by 2, and that'll get rid of our 8, and our term will become 1. So now we have ourselves right here. We've got t squared plus 8t minus 3 is equal to 0. And now we can go ahead and complete the square, just like we did in 3.3a. So let's go ahead. I've got t squared plus 8t, and I'll start off. We move the c term to the other side, and then we have our blank spots. We'll do the little completing the square part right here where we take the b term, divide it by 2. That gets us 4. We square, and that's 16. So into these blanks, we plug in 16. Our next step, remember, is we factor on the left, simplify on the right. So hopefully we realize, remember, that b term we divided by 2, that number that we come up with will be in our binomial squares. So we got t plus 4 quantity squared, and that is equal to now 19. Next step, square root both sides. We got t plus 4 is equal to plus or minus rad 19. And then we will subtract 4 to both sides. And t is equal to negative 4 plus or minus rad 19. All right, so the easiest thing to do is to get rid of that a term by dividing each and every term by whatever that is, so it'll equal 1. Let's take a look next up at number 11. And don't forget, you should be doing these on a separate sheet of paper because there's a lot of work that is involved and probably not enough space to fit everything in what you have here without it looking very cluttered and unorganized, which wouldn't be good for your notes. If we look at number 11 here, it doesn't look like number 10 because we have a 3x that looks like may have been factored out. So let's go ahead, let's start off right here. Let's distribute the 3x. So we have 6x squared plus 30x. And luckily, if you look at our c term, it's already on the other side. So we don't need to isolate it. It's already self-isolating. So I'm going to go ahead and put the blank spots right there. Now there is something that I should do. And right here, let's go ahead. Actually, even before we did that, what I would show you right here is something that I would do when I need to take a quadratic and turn it into vertex form. But actually, even before we do any of this, let's go back right here. And let's do what we did right here on number 10. Since my a term is greater than 1, let's go ahead and divide everything by 6. So now I have x squared plus 5x. And then let's go ahead and we'll put the blank spot right there. And now I have negative 4 plus the blank. All right, so now we took care of that a term. I guess I could have left what was there beforehand. But I guess to make things a little bit neat and organized for you. All right, now let's see. We got some of the fun begins. So pay close attention to this problem right here. Because we take the b term, we divide it by 2. don't forget we need to square it. So now I have 25 over 4. And that needs to go into the blanks. I say the fun begins because this is where, we're dealing with fractions here. And oh boy, good times are to be had with fractions. Our binomial should be, once again, very easy to come out because it's whatever we get when we take the b term divided by 2. So if you take a look right here, I underlined it, and we just need to plug that into play. Now it's this part, let's subtract or let's add the fractions together, and we're going to have to work on getting some common denominators. So remember, in order to get common denominators, right here, the denominator is 4. We can go ahead and multiply this top and bottom by 4. So we have negative 16 over 4. Okay. And let's add the 2 together. So negative 16 plus 25, that we should get you a 9. And then remember, denominators, you don't have to do anything more. Leave it as is. That's why we can add them up or subtract. So we're almost there. It's looking nice. Start to condense. And to get rid of our exponent, we're going to go ahead and square root both sides. And it works out nicely right here because the square root of 9 is 3. And the square root of 4 is 2. So now I have plus or minus 3 rad 2. After that, let's go ahead. We're going to subtract 5 halves to both sides. So let's go ahead and put x is equal to negative 5 halves plus or minus 3 over 2. And you should be able to come up with your 2 solutions now. Negative 5 plus 3 is negative 2 divided by 2. So one of our answers is negative 1. Let's take 5 minus 3, which gets us negative 8. We divide that by 2, and we end up with negative 4. So these are our 2 answers for x right here. Let's go ahead and move on right here to number 14. So now we've pretty much looked at every single scenario that's going to be used to be able to solve. And so some might be better than others. Now, there's always one thing that you can use is the quadratic formula. But right here it says either factor, square root, or complete the square. All right, so on some it may not be easy to use the quadratic formula because you don't know what A, B, or C is. There are some that you do. So hopefully you can recognize when you could use that. Now, like on our test, I would prefer that you use either factor, square root, complete the square. Okay, I may ask you to specifically do that, and you need to show that in your work. If you're taking like the SATs or something, then you choose whatever method you want, okay, or on the state test. So, number 14. I look at this right here, and I'd say that the easiest way to solve this is by factoring. Because if I look right here, they both share an x as a common term. So I could factor out the x, and I got x plus 7 equal to 0. Now don't forget, when it comes to quadratics, you could have as many as 2 answers. Well, how do I get the 2 right here? You always need to remember, if what's out in front right here is a variable, then you want to set that equal to 0. So one of my answers is 0. The other one, let's take x plus 7 set equals 0, and x equals negative 7. Those are your 2 answers. What I do find that students forget a lot of times on number 14 is that they don't take that x and set it equal to 0, the one that's on the outside. So they only end up with one solution. Okay. If there's a constant out in front, like 5, then you don't need to set that equal to 0. Then you'd only have one answer, and it would be x is equal to negative 7. That's if on the outside right here, it is just a constant. But if it was 5x, then you take 5x. You set that equal to 0 to get one of your answers of 0. When I take a look at 15, I notice that, look, there's no a, b, and c term, or there's a c term right here, possibly. But there's no a and b term because it's in a binomial. So if you remember what we did, one of our first steps in the last section was solving equation using, right here, square roots. Because let's get rid of that exponent and we'll square root both sides. So now I have x minus 1 is equal to plus or minus rad 35. We go ahead, we'll add 1 to both sides, and x is equal to 1 plus or minus rad 35. And look, just like that, we have our answer. There are two answers here. Don't forget, it's x plus rad 35 and x minus rad 35. Don't forget to always check to see if this is a perfect square or if it's a simplified radical. Because if it's not, then you do need to continue on. But there's nothing more that we could do with number 15. Number 16 right here. This is one of our special factors. Maybe you remember from Algebra 1. You may have heard a teacher before say dose, because this right here is your difference of two squares. So if you forgot what that is, you may want to look that up on Google. And the reason why it's the difference of two squares is, one, we have a binomial. There's a minus sign in between. And so what we can do right here, and why I'm saying that this is the difference of two squares, is because I can take the square root of the first term. The square root of x squared is x. I can take the square root of 225. That right there is 15. So the pattern with difference of two squares is that if I could take the a and the b term, or these first two terms, and I can square root them and come out with whole numbers, and there's a minus sign in between, this becomes x plus 15. X minus 15 is equal to 0. So then you go ahead and solve things out. X plus 15 equals 0 and then gets you negative 15. Okay, x minus 15 said equals 0, and you end up with x is equal to 15. So there are our two answers. You could take this and set it equal, add 225 to both sides and square root it. You would get the same answer. However, I figure difference of two squares is something that you guys will need to use and remember as we go further on in our journey here of Algebra 2. Let's see. If you look at number 4, I would say this one right here, you're probably going to need to complete the square, okay? All right, let's go ahead and give you another shot at what we're doing right here. We take the a term. We're going to divide everything by the a term, which is 4. So now we have x squared plus 2x plus 3 is equal to 0. Okay. Now, you may say, can you factor this? You can certainly try, but I'll tell you what, there are no factors of 3 that add up to 2. So, that's why right here, let's go ahead and we'll complete the square. The only other option that you would have right here is to use the quadratic formula, which is not an option that was given. So let's move the c term to the other side. We take the b term, we divide it by 2, and that equals 1. You square it, that still equals 1. So I'm going to go ahead and put that into our blanks. We will factor on the left. Remember, your binomial squared will be whatever number we came up with when we took the b term and we divided it by 1. which happens to get us positive 1. So we have x plus 1 quantity squared is now equal to negative 2. We'll square root both sides. Got x plus 1 is equal to plus or minus rad negative 2. We can simplify that, and hopefully now you're experts at this, and that's I rad 2. And let's subtract 1 to both sides, and we'll have negative 1 plus or minus I rad 2 as your answer. All right, let's go ahead and move on. Let's take a look at number 18, word problems. We start off, the area of a triangle is 30, and then they give you two sides of the triangle. Area of the triangle, hopefully you remember, 1/2 base times height. So we can go ahead and start plugging things into our equation right here. Area is 30, so plug that in for A. We have 1/2. The base right here, we can go ahead and say is x plus 2, and the height is 3x. So what you can do next is go ahead and distribute and multiply everything together. We could start off by getting rid of the 1/2. That might make things a little bit easier. And let me go ahead right here. We'll multiply both sides by 2. And then so what I'll have now is 60 is equal to, well, 1/2 times 2 is, will be 1. And then now I'll just be left with x plus 2. Actually, let's go back one step. I'm going to try to make this as easy as possible for you guys. So let's see what we can do first. Let's go ahead and simplify this. And we end up with 3x squared plus 6x. And then we have ourselves our 1/2 right here. You could distribute the 1/2. Or actually, at this point, let's go ahead and multiply both sides by 2. Because when I multiply all of this by 2, we get 2 times 1/2, and that becomes 1. So now I have 60 is equal to just 3x squared plus 6x. And then now, remember, if I want to complete the square, I have to make sure that my a term is 1. So I can go ahead and divide everything by 3 right here in our function. So now I end up with 20. Now there was a blank spot, so we'll go ahead and put that right there. And that's equal to x squared plus 2x plus the blank. This time we have things on opposite sides, just because of the way the problem was set up to begin with. So then let's take our b term we have, which is 2. We'll divide that by 2. That equals 1. We square it, and we end up with 1. So we'll put 1 on both sides right here. And let me move things over here on the right-hand side. I have 21 is equal to, and then we can go ahead, we got ourselves x plus 1 quantity squared. Okay, moving along, we can go ahead and square root both sides to get rid of the exponent. So now I have plus or minus rad 21 is equal to x plus 1. And then lastly, we'll go ahead and subtract 1 to both sides. And so x is equal to negative 1 plus or minus rad 21. So if you want to find the value of x, it would be both of those right there. All right, let's take a look next up at 19. So this is where, in order to take a quadratic function and to put it into vertex form, we're going to have to do pretty much a lot of the same steps that we have done when we were completing the square earlier on. The only thing is this f of x, or is technically y, does not go away. Okay, you have to make sure that that stays in place. So let's start, and remember, our first thing is let's make sure our a term is 1, which it is. So now what we can go ahead and do is let's move the c term. I'll subtract 22 to both sides. So now I have f of x. I'll put minus 22, and we will still need to have that blank spot, and that will now be equal to x plus 6x, or x squared plus 6x. And we'll have the blank spot right there. So let's continue through the motions. Right, everything is pretty much the same except for the very beginning, right, where we have the f of x. So next we'll take the b term, divide that by 2. We have 3 squared, and we have 9. So let's go ahead, we'll put 9 to both sides right here, and there you have it. Now normally we said we would factor on the left, simplify on the right. This time, let's go ahead, what we're going to do is simplify this on the right, or left. So negative 22 plus 9, that'll get us negative, let's see, what is that? Negative 13. And let's go ahead, we're going to factor over here, and that'll turn into x plus 3 quantity squared. Remember, the number we get when we divide it by 2. The last thing we need to do is get f of x by itself. We'll add 13 to both sides, and now we will be able to get our answer of x squared plus 3, or sorry, x plus 3 quantity squared plus 13. And now if you look at this, we have this in vertex form. The last part was identify the vertex. Remember h and k, we have h right here, k right there. We always have to take the opposite of h, so we have negative 3, 13, and that is your vertex. The last part right here, the culmination of everything that's been going on in this section. Let's take a look at number 20. A golfer hits a golf ball on the fairway with initial velocity of 80 feet per second. And then with the height in feet of the golf ball after t seconds can be modeled by the function that's given. Now the function that's given is h of t, which t represents, hopefully we now know, is time. And it's negative, right? It's negative 16 t squared. So hopefully, once again, at this point, if my a value is 16 and negative 16, then what's going on is that the function is going up and then going down. It has to be a downward facing parabola. Looking at the function, t represents, consider your value of x, right? So we can say down below right here, this is time. H, which is your x, would be your height. So now it says find the maximum height of the golf ball. What would be helpful right here is to maybe let's put into vertex form, right? Or if you remember, you could also go about solving this by figuring out the x value of the vertex, or your axis of symmetry, and then plug it back in to find y. So there are several ways to go about doing this. But since we're dealing with completing the square, let's go ahead and show you how to do that when our a term is greater than 1. This right here is important, a little tricky. So make sure you follow along with the steps. So we have h sub t, okay? And normally, once again, we would move the c term. Okay, so let's go ahead and we'll do that right now. We'll move the c term and I will subtract 0.1 to both sides. So we'll put minus 0.1 and then plus the blank is now equal to negative 16 t squared plus 80 t plus the blank. The reason why I'm showing you this way, because you're saying, well, this looks like it's much more complicated. Well, it is because your a term is greater than 1. So I'm going to show you how you deal with problems and put it into vertex form when your a term is greater than 1. Next up right here, we're going to do everything that we did before, and let's factor out. Now this time, instead of dividing everything by negative 16, we're going to have to factor out the negative 16. So I'm going to write negative 16 right here, factor that out, now I have t squared, and then for me to get negative 80, well, negative 80 divided by negative, or 80 divided by negative 16, that right there will end up being, let's see, it'll end up being negative 5. Okay. So we have that down now. Now you may say, well, why didn't I factor out so right here, I only factored out the 16 because once again right here we have to end up with a binomial squared. So now next up, let's take the negative 5. A little, need to make sure I think ahead. So we have negative 5, we'll divide it by 2. So b term divided by 2. I cannot simplify that any further, so we'll keep it as a fraction, and then we'll square it, and we have 25 over 4. So in this blank spot goes 25 over 4. Right here, I put 25 over 4. Now here's the big thing that I didn't do, and this is where students tend to forget. Because I factored out this negative 16 right here, in this blank spot, you're also going to have to plug in negative 16. And so you need to simplify all of this right here before you can go ahead and solve everything. Okay, we're almost there. Okay, now negative 16, and then when we multiply it by 25 over 4, luckily 16 and 4 divide nicely and gets us negative 4 right there. So negative 4 times 25 will get us negative 100. So let me put all the steps down. So we got h sub t minus 0.1, and all of this right here ends up becoming negative 100. All right. Once again, you could use your calculator to figure that out, but I tried explaining to you that the negative 16, or you could take negative 16 multiplied by 25 and divide it by 4, and you'll still get right there negative 100. So we'll put everything together, and I have h sub t minus 100.1, and that is now equal to negative 16. We have our binomial squared, which will be t, and then this part right here, because that's what I got, negative 5 over 2 when I divided my b term by 2 and squared. We have one last thing, and we're going to have to go ahead and add 100.1 to both sides. So if h sub t is equal to negative 16, t minus 5 over 2 quantity squared plus 100.1. So we could figure out, well, what is the maximum height of the ball? Well, since we have this in vertex form, I know my vertex is at 5 halves, comma, 100.1. So the maximum height right here, hopefully we realize, remember, 5 over 2 is x, or t for time, y is height. So the maximum height would be your value of y, and that would be 100.1. And so that is the maximum height of your ball. In the whole scope of our graph right here, what they're saying is at 5 halves, which is what, 2.5. So at about 2.5 seconds, it's already at 100.1 feet. Okay, so 100.1 feet is the maximum height. That would be in this graph that I have right here. It'll be at our vertex. Which seems to be working a little bit slow. All right. Well, once again, my tablet is lagging all of a sudden. And so hopefully you can see where it's at. The last question is, how long does the ball take to hit the ground? So that's going to be time, right? This ball is supposed to hit the ground at 2 separate spots. Think about right here. If this is a parabola, it hits at 2 spots. Now, there's a starting point and then the ending point. And so what we could figure out, remember, those are zeros. So the last thing you could do in order to find that is to take our equation and you could figure out, well, where are the zeros? I would say the easiest way to do this is to go ahead and set y equal to 0 or time equal to 0, because that's when that would be right there. And then we can go ahead and probably using the quadratic formula might be the best bet right there. But I think the main part, we'll just leave it at 20a. Well, we can go ahead and take a look at 20b. Oh, my tablet came back, I think. I think not. So how long does it take to hit the ground? We have our function, or h sub t. We want to take this right here, and we want to make sure that ground would be 0. So then we have our function right there. So what I can do, the easiest way I would say is use the quadratic formula, negative b. So we have negative 80 plus or minus the square root of b squared minus 4 times a times c. And we will divide this by 2 times a. All right. Simplify this, and you should come up with 2 separate answers. All right. So the time it takes from beginning to end, you're going to want to find that distance between the two. And so what you'll end up with right here, if you do this correctly, you'll end up with 2 answers, and it's about x being negative 0.0012, and then the other one is 5.0012. So if we look at our diagram, it's saying that's where the x happens to end up being. So from beginning to end, if we consider that whole entire distance, it's roughly around 5 seconds from beginning to end. From where it starts all the way from the other 0. So we can go ahead and say that at approximately 5 seconds is how long it will take for the ball to hit the ground. All right, because that is from the distance from here, or the time it takes from here to here. All right, and there you go. We've now finished completing the square.